Welcome back to part 2. Now we're on to challenge 5. We're going to adjust these 3 equations to make sure that they hit through these 2 dots. So what we're going to do is we're just going to mess around like we've been doing. So if I wanted to shift this side of my red parabola, well, let's see. Remember, the left side over here means this first one here, which is a plus 2, meaning it's going to be on this side at plus 2. It's going to hit the x-axis at 2. So let's see, if I shift this over, because it looks like the dot that I want is 4. So let's change it to 4 and see what happens. Oh, perfect. So the left side of my parabola hits at 4. Well, let's see, where is this dot at? 1, 2, 3. So it looks like the other side, the second set of parentheses, instead of being at 2, we should shift it 1 more to 3. And there we go. The red goes through both of those 2 points. So let's try the blue here. So the blue started out at the same points as our red, which all of these do. So now that we know what how to hit the leftmost dot over here, I need to change the plus 2 to a plus 4. And it'll hit that one. And then again, since I know that this is the third dot, the x coordinate is 3, I should change that one to 3 as well. Now for green, we're going to do the exact same thing because they were all started at x plus 2 and x minus 2. So I need to shift that one to 4, and I need to shift this one to 3. And now if we didn't really know this, we could definitely mess around and we could say, okay, let's try 2, let's try 1, let's try 0. And as you can see, my right side of my graph, or my parabola, is shifting by 1. Interesting. So we can mess with the left side of the parabola with the pluses and the minus with the right side. So if we hit our next challenge, which is challenge 6 here, this one might be a little bit more challenging. We need to make sure that we're going through all of these points for each of them. Well, based on what we know, right? Let's try, since it looks like it's just going to be on the left side of my x's, let's start with a set of parentheses. So equals, x, where is my first dot, my most points? Let's see, 1, 2, 3, 4, 5, 6. Okay, so my vertex is at 6, so we're gonna put a plus 6 and see what we get so far. Let's see what that gives us. Gives us a straight line, meaning that, hey, we forgot to square it. Okay, so let's see, if we check our work, okay. So it's a little bit above. The vertex is almost right. But remember, if we want to shift up or down with our parabola, we need to add or subtract however far down we want to go. So in this case, we want to go down 1. So we're going to say minus 1. And let's see if that works. Yep, looks like it works. So then for the blue here, I know it's going to be a negative. So as we can see, based on the last one we just did, we want to have parentheses for this one. We need to have a negative in front of the parentheses to tell it, hey, my parabola is pointing down. X, where is our center of our vertex, which is going to be at the x coordinate 1, 2, 3. So plus 3, because remember, it'll flip it the other way. Let's see how that does. Okay, so it's a little bit low. So just to prove, our A here, for our vertex formula, the A is either going to be a plus sign or a minus sign. So we need to go up or down So our parabola needs to face down, so that's why a is negative. And then we have x, which is just our standard x. H, remember, is the x value of our vertex, which we said was 3, or a minus 3, right? And then two negatives make a positive, squared plus k. So what is our k? So it looks like our coordinate right here is 1. So let's try plus 1 and see what we get. Perfect. All right. So now let's try the same thing with our green line. So we're going to use the same process here. Now we're going to use our actual equation to prove it without just guessing. So let's see. Our green needs to point up. So our equation should read y equals plus, you can put a plus there if you want. I already know it's going to be positive. So I can put plus, or you can put nothing. Remember, mathematicians don't show that this is a positive. So x, we're going to carry the x down, because that's our standard x that stays. Our vertex, which is right in the center, it looks like that our vertex is 0, negative 1. So that means I have minus 0 squared. And then I have a negative k, so I have minus 1. So since this 0 really doesn't do anything for us, we don't need to include it. So essentially what we have here is x squared minus 1. Or what we can actually do is just write x squared minus 1. So let's see if that gives us our equation here. Y equals x squared minus 1. See if we got green right. Yes. All right. So using the formula definitely helps us figure out these problems. So let's start back over with our OG formula here. All right. Our yellow, our orange, it's going to be pointing down. So I know my A is going to be minus. So then I have parentheses, x, and our vertex, our center point, it says is going to be 1, 2, 3, 1. So my vertex is 3, 1. Alright, so now I'm going to take this 3, plug it in here. So x minus, because that minus stays there, 3. And then my k is a 1. I'm going to put it here, plus 1. Now let's see if the formula has not failed us yet. Y equals negative, parentheses, x minus 3 squared. Oops, I forgot the squared here. Forgot to bring it down. Don't forget that. Plus 1. Perfect. This equation works every single time to help us find the vertex and even help us graph it. That's pretty cool. So now let's look at the purple here. I know that it's going to be pointing up or concave up. And now my vertex is 1, 4, 5, 6. So my vertex is 6, negative 1. So now I'm going to take this 6, plug it in for h. So essentially I have x minus 6, because remember that negative stays there unless our vertex was negative. And this negative 1 is going to be my k. So then we have y equals x minus 6, parentheses, squared minus 1. Let's see if we got it. Perfect! We got all of them. Awesome. So now what you're going to do is plot 5 parabolas with the same x-intercept in black. So we want an x-intercept of 4 and an x-intercept of negative 4. So what I instantly know is that all of these equations are going to be y equals parentheses x plus 4, because that's my positive 4, and x minus 4, that's where it's going to hit on my y-axis. So I can instantly copy all these down to these. Now I just need to figure out what my a is, or essentially what should go in front of those to make it true. So I can start with my red, which is about negative 80. Let's plug and chug. It's going to be pointing down, so let's try negative 2. Nope, a little bit too low. Try negative 3. Still a little bit too low, but I know that, hey look, blue is negative 3. So then, let's try negative 4 maybe. Closer. Let's try negative 5. Perfect! So I know my red and my blue are done. My green. Let's see. We said it was going down, so I believe we already did that one just as a process of elimination. Yep, we got negative 1. Well, now we have our purples and our orange. So what's really cool about these parabolas and what's cool about this Desmos is I can see, okay, so if this one hits both of these 2 points and it's mirrored over, that means green and orange should be the same, essentially. But let's see, if I do a +1, let's see if we prove that right. Nope, doesn't look like it. So let's try 2. Perfect! Because, remember, positive number in front of the parentheses means it's going to concave up. So let's try for purple. If that's there, maybe 3. Let's try 3. Nope. 4 maybe? There we go. It's a pretty colorful rainbow. And honestly, once you, if you figure out red, you can definitely figure out all the other ones. If you copied and pasted it in there, they're all going to be the same. Blue, green, orange, and purple are all going to be the same until you put a number in front of them. So let's move to 10. Which equation shows the graph? So let me make this super large. So let's see. I know that on this side I'm 2 away from the 0, right? So maybe it's a positive 2, okay. And then on this side it's gonna be 5 away. So I know I'm dealing with 2 and 5, a positive 2 and a negative 5. So it's either going to be one of these. Well, the difference between them is one is concave up and one is concave down. As you can see, it's concave up because the 2 ends go further away from each other. So it's going to be the first one up here. And you can write, I knew that it was, the positive 2 means it was 2 away on the left side, and the negative 5 means it was 5 away from the origin, however you want to phrase it for your answer. Now for the last one here, when you finish check my work, try to do it 2 different ways. So you're going to figure out a parabola 1 and 2, mess around, see what you want to create. What you're going to try to do is hit all 3 of the points. And for 9, it's the same thing, write it 2 different ways. And for 10, same thing, but now 3 different ways. And for the second to last one is, what equation could be right to produce this? Well, I know that I hit the y-axis at 8, right? So I know it's a positive 8. I know that I'm hitting my x-axis at a negative 2, and I'm also hitting it, it'd be +2 into left, and then, it looks like x minus 4. Let's see. And then you're going to answer why you think that is. And then sketch this one. Have a great day, guys, and don't forget, if you have any questions, always shoot us an email.